Well, hello there! I hope you're having an amazing day and that you're feeling eager and ready to master how our computers are basically allowing us to work with characters, because that's exactly what you will learn today. We're starting things off with our regular question, and that is, what are characters actually? And to answer it, well, basically characters are characters which allow us to represent all kinds of different stuff. We can represent letters, both lowercase and uppercase letters, and we can also represent digits and some special characters and some language-specific characters which are like Cyrillics or Chinese letters or whatever language-specific letters we may stumble upon. You can represent them all using characters. You just think about it and the characters will make it come to life. Okay, let's get serious for a second here. Let's talk about characters in Rust. First of all, Rust uses 32 bits to represent each character. So basically 4 bytes of memory are being allocated for every single character that we are using in our code. And when you think about it, 2 to the power of 32 different options is quite a substantial number of different options, but we need that many, because if you think about it, we have a whole wide array of different special characters that are bound to each specific language, and we need a way to represent them all, which is why we have to make our characters huge and represent any letter that we may stumble upon. Also, the number of emojis today is growing rapidly because we need to show our emotions in the best and more representative way possible. Rust characters represent Unicode scalar values. Do not get scared here. That is just a way to represent characters, nothing more than that. It's just a standard, something that is being agreed upon by many people and what seems to be working out for us to represent letters and all kinds of characters in a best way possible. And as we already mentioned, we are using 32 bits to represent each character, which means that we are using UTF-32 encoding on our characters. Oh my god, so many different names! Can we make this a bit simpler at least? Do not worry about this, my young Padawan learner. This should not worry you at all. I'm just mentioning these weird names and standards that are being used to represent characters, so you would have a complete understanding and a complete story, so to say, about how things work. So if you're interested in this topic and want to know how characters are being encoded and what standards exist, you can always Google it. I'll even link some information about UTF-32 encoding standard in the description of this video for you guys that are interested to be able to learn more about the topic. But for now, you should definitely not worry about this. And finally, one more thing that we need to note here is that not all ranges of values are available for us to use to represent characters. So we have specific ranges which are allowed and we are using them to represent characters, and we also have ranges which are not allowed and are not being used to represent characters. And you can basically see them on the table here on this page. Everything outside of these ranges will cause an error to be thrown, because our compiler will know that that is not a valid value for our characters to be represented with. Well, finally, we managed to get to the point that we are going to start talking about characters in real life, in action, in our Visual Studio Code. We spoke about the theoretical part of characters enough. It's time to talk about the practical aspect right now. So I have prepared quite a few examples of using characters in Rust. Of course, we are going to be starting from the most simplest of tasks and work our way from there. The first thing to note here is the fact that each character is specified by a single quotation mark. if we were using double quotation marks, that means that compiler would figure out that it's working with strings, not with characters. So a single quotation mark is reserved only for characters and nothing more than that. So as soon as we use a single quotation to specify some character, the compiler will know that it should infer its type as character type. As you can see, we have quite a few examples. The first one is we have a capital letter A, then we have a lowercase letter b, then we have a number 8, and then exclamation mark followed by a space. And you can see that the character that follows the space is basically two characters. We have a slash and n. Aren't we supposed to be using just a single character, one character, not two or three or whatever, just one? Isn't that right? Yes, but this is a single character in eyes of our compiler. The slash n character is being observed as a new row. So basically, when you tap enter key, you would get a new row. And we need a character for it, and that is why we are using slash n for. It represents a new line. Of course, we are using these special characters for quite a few other things and situations other than the ones we just covered. We can use them to represent some special characters and in some special scenarios and stuff like that. So you should not worry about it. You will stumble upon them as you go through the road of learning to code. Aha! I get it. But wait, just a second. Aren't we supposed... So how are we going to know when we are allowed to be using more than a single character? Yes, you should not worry about that, because each of these special characters always starts the same. So slash and next character are being observed as a single character, and it's always going to be a slash. Nothing else than a slash is allowed. So have that in mind. Makes perfect sense now. Thank you. In our next variable, we can see a smiley face. I told you that we have specific places and specific characters that are reserved for emojis, and this is one of those. And after our emoji, we have this special character that is taken from some of the Asian languages. I'm not sure which one, because I know for a fact only that it's not English. Everything else is a mystery for me. Also, have you noticed that each of these examples is using implicit data type notation? So I did not specify the data type for any of these variables explicitly, but our compiler helped us out, and based on the fact that we were using a single quotation mark, it knew that it was working with characters. So we can also specify the data type explicitly, and to do that we use exactly the same approach as we would regularly. So as you can see, our capital letter M has its data type specified explicitly. Another very important thing to note here is the fact that characters and numbers are not the same thing. So if we take a look at our next example, you will see that we are trying to compare a character and an integer. And when we do that, you will see that we first of all get an error, and besides that, even though we are not allowed to compare two variables of different types, we would not get true as a result of this comparison, because the data type of integer cannot be the same thing as the data type of character, even though the value number 8 and a character of digit 8 is not the same thing. And if you think about it, that makes perfect sense, because the integer 8 contains a value that is inside of our memory that is equal to number 8 converted into its binary representation. And when it comes to character of a digit 8, we would not get that value. The digit of number 8 inside of a character is something completely different from that when it comes to binary representations. So even in the memory, the layout would not be the same. Another thing that you must have in your head at all times is the fact that arithmetic operations do not work on characters. Even if inside of those characters we have digits, it is not going to work. So take a look at our next example, and if you see, we get an error because the plus operator is not allowed on two characters, and our compiler is telling us exactly that. So yeah, this does not work, so do not try it out. You can do it by converting each character into the number itself and then use the operators, but without the conversion and when working with character type itself, it is not going to work. And finally, we will end things with a style. I have prepared a special example here where I'm going to print out all the characters that are starting from value 0 all the way to 255, which is the maximal value for U8 data type. And when I run this code, we will basically go through numbers 0 to 255 and convert each number into its character counter representative. And when we run the code, we can see that we do get a whole bunch of characters, starting with some symbols, then we have some empty spaces, and after that we have some symbols again and some more empty spaces, and finally we are reaching the point where we have digits and then some characters and then letters. Basically, that was only for the first 256 characters. We have a whole bunch more that are not being displayed here because this is U8 data type. Just imagine how many more options would we have if I used U32 data type, which is the equivalent of 4 bytes of data, which is the amount that was used for storing characters. And that, my friend, was everything about characters I have prepared for you in this video. I hope that you enjoyed it and found it useful, because if you did, I would really appreciate if you could spend a second and subscribe to this channel and like this video, because it's definitely going to help out both me and the channel to grow and spread the word about Rust programming language to as many people as possible. And for this, I'm so thankful to you. And in our next video, we will be extending our knowledge about characters, because we are going to be talking about basic methods that are being built into Rust programming language to manipulate characters and work with them in easy and understandable fashion. So, if that sounds interesting to you, please feel free to join me in my next video. Until then, I wish you an amazing day. Goodbye!